So let's talk about number one, and then I also want to do the part where we're writing equations for it. Has anybody started doing the equations for these? All right, so let's start off here. I find it helpful to label these horizontal lines by looking at the y-coordinates. I know that this one's at 3, this one's at 0. I don't have a point, I don't have coordinates for this point, but I do know that a sinusoid, if this is the midline, and it tells us that it is the midline in the instructions, that the amplitude is going to be the same in both directions. So it looks like my amplitude is 3. So this would also be 3. So this line is going to be 3 down from 0, negative 3. Okay. So what else do I know? So when we did this, we remember how we drew these kind of frames and everything was split up nice and evenly? If you remember that fact, that's what's going to help you figure out where the x coordinates. Oh, you know what? I should go ahead and fill in my y coordinates here. So for the missing points, A would have a y coordinate of 0, and B would have a y coordinate of negative 3. C would have a y coordinate of 3, and D would have a y coordinate of 0, because they fall on those lines. To find the x coordinates, we just need to figure out what our period is, or I actually usually look for what a quarter of the period is, because that's going to be the distance between these key points. So that's not the full period, that's a quarter of a period. I can tell by looking at my x coordinates. This is going from an x coordinate of 2 to an x coordinate of 3, so these must be 1 unit. So every time we go to the right by a point, we're going over 1 unit. So my x coordinate is 3 here. Over 1 is going to be 4, over 1 is going to be 5, over 1 is going to be 6, which matches up. That makes me happy. Over 1 would be 7, over 1 would be 8, and we've got all of our coordinates there. How many people were able to figure out those 4 missing points on your own? Were a few of us able to do that? Oh, good for you guys. Excellent. That makes me happy. Can one of you put that chair down for me, please? Thank you. So the folks behind you can see a little better. All right, we want to write an equation here, and I have asked you to write a sine and a cosine equation. Why don't we go ahead and figure out the parts of the equation that are going to be common between those things? Between a sine and a cosine, the amplitude doesn't change, right? The period doesn't change, so omega doesn't change. The vertical shift doesn't change. The only thing that changes is the horizontal shift. So let's find all the other stuff first, and then we'll come back and fill out the rest of it. So I know I'm going to write a sine and a cosine. I'm going to go ahead and kind of get it set up here. I'll do a sine and a cosine. I'm leaving some space in front for my coefficient. I know my format's going to look like this. We're going to do both. Yeah, so the big thing, if you weren't here yesterday or Wednesday, the big thing that you missed is, remember I told you last week that I kind of was fibbing to you a little bit, or I was hiding some information from you? The information I was hiding is there's really no such thing as a sine separate from a cosine. Every one of these graphs is a sine, and it's just shifted left or right. So I can shift a sine to the right and make it into a cosine. All right. So, well, amplitude, we know the amplitude. The amplitude is 3, so it's going to be a 3 in front of both of these. We might decide to put a negative in front of one of those 3s, but we'll deal with that in a second. The other thing that's going to be the same would be our omega. Remember, omega is 2 pi times the reciprocal of the period, t. And what is our period here? It's 4. I'm kind of looking from peak to peak here. That would be 1 full period, right? And I'm going in the x direction from 3 to 7. So yeah, so the period is 4. So my omega would be 2 pi times 1 over 4, or pi over 2. That's going to be the same for both of them. The other thing that's going to be the same for both of them will be your vertical shift. Does this one have a vertical shift, though? So the midline is at 0, which is where it would have started anyway, so this does not have a vertical shift. We could write a plus 0 there, but we usually don't. So take that away. So then all I need to do is figure out how far left and right we've shifted for a sine and a cosine. So let's talk about the sine. Give me an x coordinate where you see a sine starting. Positive or negative, doesn't matter to me. 2, you're looking at this point here. So I see a sine period between those two places. Yeah, that'll work for us. And that's a positive sign, agreed? So we'll leave this positive. So normally this point right here would have had an x coordinate of 0, right? It would have been at the origin, but we've shifted it. It looks like we've shifted to the right by 2, agreed? To the right by 2 means I need to put a minus 2 in there. And then cosine, are you seeing a positive cosine or a negative cosine? I see a negative cosine starting here, but we don't have an ending point. But we could use this. Or we could use this positive cosine. You guys have a preference? Either one's fine. We'll use this one. So this one starts at 3. If it was not shifted, it would have been starting in an x coordinate of 0. But this has been shifted. It looks to the right by 3 this time, so a minus 3 there will get us our answer. Yeah, that's it. I left some blanks up here for you to put the coordinates of the points, but if you just label the points, that's fine by me. This is going to be part of your assignment, so I want to show you how you can check, because I'm not going to be providing an answer key for this. Okay, so I'm going to check my equations now. I'm going to put this equation into my calculator, but when I get to the x value, I'm actually going to put a number in here. I'm going to first put a 2 in and hope that I get 0 for my answer, and then I'm going to put a 3 in and hope I get 3 for my answer. Then I'm going to put a 4 in and hope I get 0 for my answer. Now this can go a lot faster. You guys have your calculators out. This can go a lot faster for us if we utilize a nice function of our calculator. So I want you to go into your y equals. We're not going to graph these things. We're going to use the table instead. Okay, so go into your y equals, put your sine and your cosine equations in. 3 sine. Be careful with your parentheses. Bless you. 3 cosine. Now I could graph this. I could set up a window based off of what I'm seeing here and make sure that these points are all on there. These ones are a little bit weird though, because you're not always going to see your x-axis. I would rather just check the points. So I'm going to let you get that typed in. Don't worry about hitting the graph button because we're not going to graph it. We're going to instead look at the table, but I want to change some settings before we fire up the table. So I'm pausing here. Give me the universal sign if you still need a minute to get those into your calculator. Okay, get them typed in here. I'm going to pause for a little bit longer. And then I want to show you how to set up a table so that we can give it some specific x values and ask it for y values. Okay, we could just go with the standard table for this problem, but when you get to these later ones where the x values are, you don't want to have to be scrolling from 250 all the way down to 360. So let me show you how we can specify what x values we want to see in our table. So I'm going to move on now. I need everybody's attention here. Please do not miss this. Okay, this will make your life easier. I need you to go into your table settings, which is second window. And I want you to go down to where it says independent. It says auto. I want you to turn it to ask instead. Now, you'll want to, at some point you're going to come back and you'll want to change this setting back, but this is going to be most helpful for us. So now if you go and hit second table, you're going to see a blank table. Now if you don't see a blank table, if you have, for example, 42 in for one of your x's, what you can do is highlight that x value and just hit the delete button. No, how do we clear it? Yeah, so highlight the x value and hit a delete button. So if you're seeing stuff in there, just hit delete until it's blank. Okay, are you guys seeing a good blank table on your screen? Yep. So here's what I'm going to do now that I got my table in here. Remember that y1 was my sine and y2 was my cosine. I'm going to start plugging in my x values and make sure I'm getting the right y values. So let's go ahead and put 2 in for x. So type in 2 and hit enter. And that's going to start the first row in your table. And we're hoping to see y values of 0 for both of those. That makes me feel good. Let me try 3. And we got 3s. Great. If I put in 4 into both of those, I'm getting 0, which is what I want. If I put 5 in for both of them, I get -3. 6 gives me 0. 7 gives me 3. And 8 gives me 0. So my points are correct. My equations match the points. We're looking good. Okay? And then remember to, if you're going to probably want at this point to clear out your table because you'll be using different values when you get to the next one. So I'm just going to go through and hit delete on each of these and clear them out so that I'm ready to check my next one. Oh, do you know a trick? Hang on. 2, 3, 4, 5, 6. So you said if I go all the way up like to the top and then just what? Oh, and then you just shift up. So you can just like spam delete until it's, oh, I don't know what happened there. All right. Okay, so I would love for you guys to continue the work on this. Okay, I'm going to pull you back in about 15 minutes or so. I will tell you that when you get to 7 and 8, these are kind of the ultra spicy problems on this sheet. And I got some hints there for you, but I'm not going to be doing these problems for you. I'll give you some more hints if I need to. I'll tell you what I would do if I were in your shoes. Let me give you a good recommendation. Could you guys please stop? Thanks. I would try and make sure you got the first 3 of these. Finish up 1, 2, and 3. And if you're checking and your answers are good for 1, 2, and 3, then I would maybe have a look at 7 and see if I could tackle 7. We'll have a little chat about 7 here before we move on to our next phase. So about 15, 20 minutes you got right now. I'll be checking assignments, so please have those out for me. We'll come back together and look at 7 in a moment. All right, guys, let me get your attention here. Let's talk about number 7. So I asked you guys to do like the first 3 and then move on to 7. How many people got a chance to try this one? Not too many. Okay, so let's at least get you started on this, okay? Before we do, as an aside, and you don't need to write this down, but just look up here for a second. If I asked you to solve the equation sine of x equals, I don't know, let's say 1/2. You've actually solved the equations like this. How would you do it? You could do an inverse sine on both sides, and if your calculator was in degree mode, does anybody know what we would get for that? What angle in degrees gives you the 1/2? Reference triangle in the first quadrant, sine is opposite over hypotenuse. What angle is going to get me that 1 and that 2? That looks like a 30, 60, 90 triangle to me. Is it the 30 or the 60? It's the 30. So if I solve this, I'm going to get x equals 30. But we would maybe want to do it in radians, so maybe we wouldn't write 30. We'd write x equals what? 30 is pi over 6. Okay. All right, now again, you don't need to write this down, but please pay attention. What if I had something like this? The sine of 3x equals 1/2. Oh, man, that gets complicated, doesn't it? Isn't this kind of the same equation as this, except instead of an x, it's a 3x? So if this is true, wouldn't you say that 3x would be pi over 6? Instead of x is pi over 6, we'd get 3x equals pi over 6? You follow my logic here? And then would you be able to solve that and figure out what x was? What would you do on both sides? We could divide by 3 on both sides, and then we could get x. And fraction divided by 3, we'd multiply the denominator by 3, get pi over 18. Okay, keep that in mind because we're going to have to solve an equation. All right? So, number 7, the only point that jumps out at me is b. I know that these sinusoidal functions are symmetric about their maxes and mins. So, well, I know by the fact that this horizontal line tells me that these 2 points are level with each other horizontally, which means they should have the same y coordinate. So I know that's 30. And if we're symmetric about this max, then this distance should be the same as this distance. And I know that the first distance goes from 40 to 50. This is 10. So this would also be 10 in the x direction. So I'm thinking this would be 60, 30. Are you guys all comfortable with that point? Now, a major common mistake would be my students might think that it's also going to be 10 from here to here, but it is not. Okay, it is not. The only things that are even are kind of our key points, our maxes and our mins and our x-intercepts. Those things are evenly spaced, but when we start adding extra points sort of in the middle of a curve, that goes out the window. Now, there has to be symmetry, but there is nothing saying that the distance from here to here is the same as the distance from here to here. Okay, they are, in fact, I can see that they're not. So how are we going to find C? Well, the answer is we're going to have to write the equation in order to figure out what C is. So let's try and write an equation. Now, if you were looking at this problem with the kind of the information that's given here, would you be thinking about writing a sine equation or a cosine equation? You're looking at a negative cosine because we have this point here, and that's where a negative cosine would start. So let's start writing a negative cosine equation. Y equals negative, I don't know my amplitude yet, but I know it's going to be negative cosine. I'm just going to set up the format of it. And I basically have 4 parameters that I need to find here. I need my amplitude, I need omega, I need a horizontal shift and a vertical shift. Anybody want to tell me what the amplitude is? What is it? Where are you getting 20 from? So this is y equals 20. Oh, yeah, and then from here to here, that would be our amplitude, right? Are we all agreed that that's 20? Okay. We're on our way. In order to do omega, we need a period. Can you tell me the period yet? Let's come back to that. How about a horizontal shift? How about a horizontal shift? I think that's, you're close. You're on the right track. Yeah, we've moved to the right by 50, right? If we're doing a negative cosine, so this would be a minus 50. How about a vertical shift? Plus 20 or plus 40? Or is it 20? Do we shift to the bottom or do we shift to the center line? It's the center line. So plus 40? Huh. All right, hey, we've got 75% of our equation written now in terms of the parameters. The only parameter we're missing is omega. Man, I feel like we've been here before. I'm thinking about some of the stuff we did in first semester. Do you guys remember when we were writing polynomial equations? And we wrote, like, we couldn't figure out what A was, but we were able to find, like, these factors. Do you remember doing this? Do you remember how we eventually figured out what A was for this? We plugged in, we stuck in a point, we stuck in an X and a Y value from some point that was on our graph. Do you guys remember doing that? We did that. We've done that at least 3 times this year. We did it with polynomials. You did it when you were finding an A value for a quadratic. And last unit, we did it when we were trying to do logistic and exponential functions too. So we've seen this come up a lot. No reason it's not going to work here. So give me another point that would be convenient here. I'm going to tell you that you don't want to use this 50 because it already appears in the equation. Weird stuff's going to happen if you do that. I would be inclined to use the 40, 30 because it was given to me, but I'm pretty confident in this, and I know that I want to use this if I want to avoid negatives inside of here. It's going to make things easier. So I'm going to use an x value of 60 and a y value of 30, and we're just going to put those into this equation and solve it. And then we'll know what omega is, and we'll be good to go. And then once we have omega, we can figure out what everything else is. So I'm not writing x, I'm writing the x value, which is 60. And we have the algebra skills to solve this. Now, we're going to be a lot more equipped to solve this when we get into trigonometric equations in the next unit. But you guys can do this. I'm thinking that plus 40 would be easy to get rid of. Minus 40 on both sides. Minus 40. So I got negative 10 equals negative 20 cosine omega. And then 60 minus 50 is just 10. Why don't we just call that 10 omega in there? That would be a simpler way to write that. What's our next move algebraically? Divide by negative 20 on both sides. Well, this is starting to look familiar. That's a half, isn't it? 1/2 equals cosine 10 omega. Is it? Okay. Now, I'm going to think about this 10 omega. Well, let's just use our calculator. You guys were more familiar with the inverses, so let's do it as an inverse. But can I get you guys to put your calculator into degree mode? There you go. You got it. You had the right period. You're thinking of the right period. You just forgot the 2 in your 2 pi. So if I did an inverse cosine on both sides, I would do the inverse cosine of 1/2. Now, when you guys are getting ready for your next memorization quiz, which will not be, well, that'll be next week. Yeah. You'll be able to do this without punching it in your calculator. But that's 60 degrees. So 10W, what I did here was I did an inverse cosine on both sides. That cancels my cosine. And I got 60 degrees. Now, when we do, when we're trying to find omega, we don't want it in degrees. We want it in radians. So let's just change that 60. We know what that is in radians. The inverse cosine of negative 1/2. You just type second cosine and put a half in there. Question? It's like an angle. I'm just thinking of it as an angle. Yeah. So at some point, you're going to memorize that the cosine of 60 is a half. That'll be on our next memorization quiz. The cosine. So you'll look at this and you'll say, oh, what angle can I take a cosine of and get a half? And you'll say, oh, 60, which is pi over 3. So these are the same equations. I'm just converting from degrees to radians here. Because when we're graphing, we want to be in radian. I'm trying to write an equation of a graph, so I want to be thinking in radians. All right, so finish this up. Divide by 10 on both sides, and you're going to get pi over 30 for omega, and that's it. Omega's pi over 30. Question? So my final equation is just going to have, in place of this omega here, it's going to be pi over 30. Which means, what is my period if omega is pi over 30? 60. So now I've got enough information to start finding these other points. I know that the full period is 60. So from here to here is 60, which means from here to here must be 30. That you what now? We put in 60. Are you talking about this 60 here? I didn't put this in, but that's a coincidence, yes. Yeah, it's not going to come out to pi over 400 in this one. All right. You guys feel confident that you can find A and B and C in that? Well, we already found B. You can find A and C. I am going to tell you, okay, when you get to this last problem, you're going to follow a similar pattern. You'll probably be doing a positive cosine for this one. And your omega is not going to work out to be something nice in terms of pi, which is why I've asked you to round your omega value to the nearest 10,000th. How many decimal places is a 10,000th? How many zeros are in the number 10,000? 4 zeros? That means I'm looking for 4 decimal places. That sounds right. I think, unless I've stored something else in that variable. Is that what you're getting?
It's like a few decimal points off. I might have made a little mistake.
Okay. I might have changed the problem, too, between working it. I don't have a key for it yet. Okay. Does anybody have any questions on the front side of this? Anything that you're just still a little unsure of? Really, what I'm hoping that you're getting out of this is that there's symmetry in these graphs, and that if you've got a few points, then you can usually find a bunch of other points. Once you've got some points, my hope is that you're starting to feel comfortable using the coordinates of these points to come up with these 4 parameters: our amplitude, our omega, horizontal shift, and a vertical shift if there is one. All right, we're going to shift gears. The reason we're doing this today is because this is going to aid us a lot in what we're going to do next, which is some word problems. So